In this podcast, we're going to explore the science of gravity and friction. So, Ben, what actually is gravity?
If you have any two objects which have a mass, they will attract one another. Now, this means that if no other forces are acting, they will accelerate towards each other due to the force of gravity.
So does this mean that I'm being pulled towards you by the force of gravity?
Well, yes, you are, but the force is absolutely tiny, about 1/1,000,000th of a newton at this distance. But it is there. For the force to be noticeable, you need to be near a much larger object, for example, the Earth.
So I'm being pulled down towards the Earth?
Yes, that's right, and this is what gives you your weight. If you're at the surface of the Earth, every kilogram of you feels 10 newtons of force pulling you down towards the Earth.
So what's the difference between mass and weight?
Well, they're often confused, but they are definitely different. Mass is the property of an object that makes it hard to accelerate. That's measured in kilograms. It will remain pretty much constant wherever you are. Your weight, on the other hand, is how much force you feel due to gravity. It's measured in newtons, and on Earth it's almost always about 10 times your mass.
So if I wasn't on the Earth, would my weight be different?
Yes, that's right. On the Moon it would be about 1/6 of your normal weight, and if you stood on a more massive planet like Jupiter, it would be much more.
So how do I actually work out my weight?
You need to multiply your mass by the gravitational field strength you are in. So on Earth, gravity is about 10 newtons per kilogram, so you multiply your mass by 10.
So if I have a mass of about 60 kilograms, on Earth I weigh 60 kilograms times 10 newtons per kilogram, so that's 600 newtons.
Yes, that's right. And if you jumped off something, because every kilogram of you is being pulled down by 10 newtons, and acceleration is force divided by mass, you will start to accelerate at 10 newtons divided by 1 kilogram, so 10 meters per second, meters per second squared, the gravitational field strength on Earth.
And is that the same everywhere?
Everywhere on the Earth's surface, but on different planets it would be different. For example, the gravitational field strength on the Moon is much smaller than on Earth. So if you look at films of Neil Armstrong, whenever he jumps, he falls back down very slowly.
But if you do fall, do you continue to accelerate as you fall?
Yes, you do, and on the Moon you would, because there's no air, and everything accelerates at the same rate. So a feather or a hammer will take the same time to hit the ground. But on Earth we have an atmosphere, and so air resistance becomes important.
And how does that affect things?
Well, when you first start to fall, you'll accelerate at 10 meters per second, but as you pick up speed, you'll start to feel the force of air resistance slowing you down, and this gets larger the faster you're going.
So it's the air resistance that slows you down?
Yes, because it's acting in the opposite direction to gravity, it will mean that you accelerate less quickly. Eventually, you'll reach a speed that will mean you stop accelerating and reach a constant speed that we call your terminal velocity.
And is that terminal velocity always the same?
Although the gravity on an object is always the same, the air resistance can change a lot. Now, for example, if a skydiver was falling and he spreads himself out, and then he moves so that he's falling head first, he'll reduce his air resistance for the given speed, and that means he'll accelerate and his terminal velocity will increase.
So what happens if he opens his parachute?
Well, when he opens his parachute, his air resistance increases hugely and will be much more than his weight. Now, this causes him to accelerate upwards, making him slow down. Another time frictional forces are important is when you try and stop a car.
And what affects how quickly a car will stop?
Well, it's to do with the amount of friction between your tyres and the road, and to do with the mass of the car.
Why is that?
Well, you're basically trying to accelerate the car backwards as fast as possible. Acceleration is equal to the frictional force your brakes are applying divided by mass, so the larger the force and the smaller the mass, the quicker you'll stop.
So the more stuff I put in the car, though, that will give it more mass, and therefore it will slow down how quickly it can stop.
Yes, that's right, and if anything reduces the friction between you and the road, that will also slow down how quickly you can stop.
And what sorts of things might do that?
Well, if you have bald tyres, or your brakes are damaged so they don't work very well, or if there's anything on the road that will lubricate the tyres, like water, ice, or oil, or loose gravel. The other big effect, of course, is your reaction time.
So in other words, how quickly I can stamp on the brakes?
Yes, of course, and because you're moving the fastest when you're making that decision to brake, this uses up a lot of distance. Your reaction time, of course, is affected by the visibility, how tired you are, and of course if you've consumed any alcohol or drugs, that'll slow you down.